This is Apollo Saturn launch control, T-minus 55 minutes and counting, and the countdown continues to go well.
Cape Kennedy, April 11th, 1970. Launch control. In just a little under an hour, the job of launch control for Apollo 13 will be over.
What's a computer and how does it work? A computer is made up of these 5 basic levels: transistors, gates, arithmetic logic unit, central processing unit, software, and memory. So to start at the beginning, what is a transistor? Well, a transistor uses a property called semiconductivity. Semiconductivity, or semiconductors, are simply just faucets of electricity that are controlled by electricity. The material used to make these semiconductors are most commonly sourced from silicon, which is basically just sand. There are different types of semiconductor combinations which are controlled by either voltage or current, but for the simplicity of this video, I won't cover that. All that I will say about controlling these transistors is that a high voltage means a 1 and a low voltage means a 0. Some transistors operate in the reverse manner. Transistors alone aren't very powerful. However, this next level is where everything comes to life. Transistors are used to create something called logic gates. What are logic gates? Logic gates use something called Boolean logic. Its creator, George Boole, created a theoretical operation system in 1847 which, given simple inputs, would alter the output if these inputs were put through a system. A quick example of a system is x equals y. For every input x, the output is y, or if I input 25, I get out 25. The operation system created resulted in these basic logic gates: AND, OR, XOR, buffer, NAND, NOR, XNOR, and NOT gates. The way of understanding these systems use something called a truth table, which again, like the example given above, describes how an input is processed through a system and then outputted. Here are some truth tables which describe these logic gates. As you can see, given two inputs A and B put through a system will give you the output of that logic gate. Another thing to keep in mind is that a logic gate can have infinite amount of inputs but a single output. The system or gate will not change its properties however many inputs are present. Now, to show you how the logic gate relates to transistors, here's a diagram of a simple AND logic gate with two inputs A and B and a single output. Even though the circuit to the left is somewhat complicated, all logic gates are comprised of transistor configurations which result in different logic gates. The combination of logic gates can create adder and subtractor circuits for binary operations. These circuits look like this. The way these circuits work is by using binary operations for adding and subtracting. The combination of these logic circuits, such as having an adder circuit and a subtractor circuit, creates an ALU, or arithmetic logic unit. Now, the ALU is basically the heart of a central processing unit, or CPU. The central processing unit uses memory to load a command, process that operation through the ALU, then sends the result back to memory. You might have heard of 32-bit or 64-bit systems. Well, this means that the system can handle up to 32 or 64 binary bits in both processing and memory. Now that we've talked about transistors, logic gates, arithmetic logic unit, and central processing unit, let's talk about software and memory and how that relates to hardware. The way software works is by retrieving information from memory and then feeding this information to the CPU, which then, after processed, is placed back in memory. The information sent to the CPU is programmed in something called assembly. Assembly uses a format of simply having the desired operation, this is called an operand, such as adding or subtracting bits, and then the desired output and input registers for the operation. This simple assembly example adds register 1 and 2, then stores the result into register 3. When a developer is ready to run his or her code, the assembly code is converted into binary, which then is processed by the CPU. All software fundamentally runs off of assembly. Memory is used to store CPU commands and also CPU results. By having memory, we can store large amounts of CPU commands, which in turn can run operating systems such as Windows or Linux. So in this video, we covered what a transistor is, how combining transistors creates logic gates, how combining logic gates creates logic circuits, how the combination of these logic circuits creates an ALU, how the CPU is just a combination of an ALU and memory, and finally we covered what software is and how that applies to memory. Hope you enjoyed the video. This video is a simple walkthrough of how a computer works. Click that like button if you liked the video, or subscribe if you loved it. Hope you guys have a great day. Peace.